Okay, let's do more about solving quadratic equations. Let's see this one. Let me get my pen. Let's see the first one. So the first one is seen using the square root property. So what is the square root property? Let's make a simple example first. Let's see if I have x squared equals to 4. Then what I could do with this is, let me change my color. I can square root both sides. I can square root both sides. But then I have the positive, negative two things, but I'll explain that why. Remember, when we talk about the radicals, right? When we talk about radicals, if we have x raised by n, then the index is n, we can write it as rational exponent form. The power is in the numerator of the rational exponent. The index is in the denominator of this rational exponent. And what we want is if n, so if n equals n, if the index and the power are the same, then what happens? Then this is equal to x, right? Because we have x raised by n over n, which is x raised by 1, which is just x. So in that case, if mn equals to 2, we have x squared, then square root. That's x raised by 2 over 2. That's x raised by 1. That's just x. If we have a cubic root of x cubed, that's just x, right? So on and so forth. So that's why when we have x squared, we can square root, because this index is 2. We can square root. Then we square root both sides, or square root 4 also. And square root 4, it's just 2. But when we have positive and negative 2 values, think about it. 2 squared is 4, right? So that means x equals to 2. And also negative 2 squared is also 4, because the negative 2 times negative 2 is positive 4. So that's why when we square root, or when the index and the power are even numbers, we always include the negative values in the 2. So in this case, let's say 8. In 8, do we want to square root both sides right away? Probably don't, because we see 3 is a factor on the left-hand side, and also 3 is a factor on the right-hand side, right? Because 21 is 3 times 7. So what we could do is we just simplify the equation first. We divide by 3 on both sides. 3x squared divided by 3, you get x squared. And the 21 divided by 3, you get 7. Now we can square root both sides. So we square root both sides. We got a positive, negative 2 values of square root of 7. So we got x equals to positive square root 7 and negative square root 7. And usually this is a lazy notation. We just write it in one time. So this means x is positive square root 7. X is negative square root 7. So this is a shorthand writing. X equals to positive, negative square root of 7. So we have 2 solutions for the first one. So this is called a square root property. We want to use in these kind of scenarios. All right, let's see B. B, let's move 25 to the other side. It becomes negative, right? Positive this side. When we move to the other side, it becomes negative. So 0 minus negative 25, we get negative 25. Then this side we have 16x squared. Now we want to square root. If we want, also we could divide it by 16 on both sides. If we divide by 16, we get x squared equals to negative 25 divided by 16. Then we square root both sides. So square root property, we square root both sides, get a positive, negative 2 values. just keep writing over here. Then we have x equals to positive or negative square root of 25 over 16, but be negative. But remember, what's the square root of negative? That's I. So we write like that. Then we know square root of 25 is 5. Square root of 16 is 4. We can write an I up front, or we can write an I behind 5 over 4. So for B, we got two values, positive 5 over 4i and negative 5 over 4i. Two imaginary solutions. Imaginary solutions. Okay. Now let's see 2. So 2 is seen by completing the square. Remember, by completing the square, what do? First, we move. We don't really have to move this one, right? So the key point is take this number, the number before x, divided by 2. So 10, positive 10 divided by 2, we get a positive 5. What do is we add positive 5 square, we subtract positive 5 square. If we move this 12 to the other side, become negative, we can add 5 square on both sides. Right? So it's the same as this. This is a minus. We move 12 to the other side, becomes negative. Then we add 5 square on both sides. Okay. So x squared plus 10x plus 5 squared, that's x plus 5 squared. That's a perfect square. And 5 squared, 24 minus 12, that's 13. So we have made a perfect square on the left-hand side. Right? Remember perfect square, a plus b squared equals to a squared plus 2ab plus b squared. So the method for completing square is focusing on the number before x divided by 2, then add the number square on both sides of the equation. So now we can perform square root property. We square root both sides. So get an x plus 5 equals to plus minus square root of 13. Then x equals to negative 5 plus minus square root of 13. We've got two irrational solutions, right? Negative 5 plus square root 13 and negative 5 minus square root 13. So two irrational solutions. All right, now let's see B. B, okay, here we have x squared. The number before x squared is 1. So what did we do is, what we did is we take 10 divided by 2, right? We add 5 square on both sides. But now we do the number before x squared is 2. So what do we do with this? We would divide by 2 first. So we can move this negative 5 to the other side, become positive 5. Then we divide everyone by 2. By dividing 1 by 2, so we get x squared minus 3x equals to 5 over 2. Now we just have to deal with fractions. Now we take the number before x, which is a negative 3, we divide by 2, which is a negative 3 over 2. So what we do is we add negative 3 over 2 square on the left-hand side. We add negative 3 over 2 square on the right-hand side. Then these three terms becomes x minus 3 over 2 squared. And simplify this one, we get 9 over 4 plus 10 over 4. Because we multiply 2 over 2 or 5 over 2. Then this becomes 19 over 4. So we have x minus 3 over 2 equals to 19 over 4. No, I mean this is square. Square. Then we want to square root. So we apply square root property. So we square root both sides. We get a plus minus 2 values. So we get x minus 3/2 equals to plus minus square root of 19/4. Simplify this. We take negative 3/2, move to the other side, become positive. Plus minus square root of 19. The denominator square root of 4 is 2. So also have 2 irrational solutions. So this is telling us if the number before x squared, when we apply a completing square method, if the number before x squared is not 1, we will factor it, or we will divide by the number to manufacture 1 in front of x squared. So basically we change the coefficient of x squared to be 1. Then we use a method, take the middle term, the number before x, we divide by 2, then add the number square on both sides of the equation. Let's see, 3, 4, 5. So 3, we want to use a quadratic formula. So let me remind you quadratic formula. When we have the standard, oops, not a squared. We start with this equation, ax squared plus bx plus c equals to 0. Then the solution for this equation is x equals to negative b plus minus square root of b squared minus 4ac all divided by 2a, right? So this is called a quadratic formula. So in our case, we need to figure out a, b, c. So we see a is 1. A is the number before x squared, 1. B is the number before x, negative 6. C is the constant term, which is 3. So x equals to negative b, negative 6, negative 6, plus minus b squared, which is negative 6 squared, minus 4 times a, 1, c is 3, all divided by 2a, 2 times a, 2 times 1. Negative 6 become positive 6, and plus minus square root. Negative 6 squared, 36. 4 times 1 is 4. 4 times 3, 12. And then divided by 2 times 1 is 2. So we have 6 divided by 2 plus minus square root of 36 minus 12, which is 24. Divided by 2. Simplify square root of 24, because the square root of 24 is 4 times 6, right? Square root of 4 times square root of 6. Square root of 4 is 2, so 2 radical 6. So we have 6 divided by 2 is 3. Then plus minus 2 radical 6 divided by 2, that's just radical 6. All right, we have 2 irrational solutions. That's a quadratic formula. Now let's see 4. Find the value of the discriminant. What is a discriminant? So in the quadratic formula, so this part here under the square root sign, b squared minus 4ac, b squared minus 4ac, that's a name, discriminant, b squared minus 4ac, discriminant. So we want to find the value of the discriminant, and then to tell what kind and how many solutions of each equation would have if solved. Well, let's think about this. Let's think about b squared minus 4ac. So first it could be 0, right? If b squared, so first situation, if b squared minus 4ac equals 0, our quadratic formula becomes negative b over 2a. It's one value. Because that would be plus minus 0. It's nothing. So left is negative b over 2a. So x only has one value, negative b over 2a. The second situation is if b squared minus 4ac is positive. If it's positive, just like this, right? We have a square root of 6, positive. Then we have two irrational solutions. Maybe two irrational solutions. The first case, we just only have one solution. The second case, we have two irrational solutions. So that's why we're seeing irrational solutions are common in pairs. So the third situation is the discriminant b squared minus 4ac is a negative. It's negative. We have a square root of a negative number. Right? In that case, we have two complex solutions. We have two complex solutions. Right? Because square root of negative number, that's I, imaginary number involved. So those are the three situations. Oh, actually one more situation, number 4. Number 4 is if b squared minus 4ac is a perfect factor. Let's say it's something squared. Let's say it's k squared. Then what happens? Then when we square root this, we get positive and negative k. In that case, so then the solution becomes x equals to negative b plus minus k. K is a whole number, integer divided by 2a. We don't see square root. We don't see I. See, this means we have two rational solutions because we have plus k or minus k. Two rational solutions. So 4 cases. So I have 4 cases. So let's leave that. Let me change my color. Let's see A equals to 9, B equals to negative 6, C equals to 1. Now B squared minus 4AC equals to negative 6 squared minus 4 times 9 times 1. Negative 6 squared is 36. Minus 4 times 9, 36 times 1, 36. We get 0. Right? Well, that's the first situation. Right? The first situation. Then the x value just equals to negative b over 2a. In our case, it's a negative. B is negative 6 over 2a, 2 times 9. Negative become positive. And this is 9. That equals to positive 6 over 2 times 9. 6 divided by 2 is 3. 3 and 9, that becomes 1 over 3. So that's 1 over 3. Okay, so x has only one solution. So what does this mean to us? When the quadratic equation only have one solution, do we see 9x squared minus 6x plus 1 can be factored as 3x minus 1 squared? It's a perfect square itself, right? You see, 3x squared give us the first term, 9x squared. 2 times 3x, 6x, times negative 1, that's negative 6x. That gives a middle term. The negative 1 squared is positive 1. So 9x squared minus 6x plus 1 can be written as 3x minus 1 squared. Then when we square root both sides, we have plus minus 0. So 3x minus 1 equals to positive negative 0. 0 doesn't have positive or negative, right? It's just 3x minus 1 equals to 0. Move negative 1 to the other side, positive 1, divided by 3 on both sides. So x equals 1/3, right? So when we have one solution, so we know the equation can be factored as a perfect square. Now let's see 2. I'm running out of space. 2, let's do b. So a equals to 5. B equals to -4. And C is tricky. C is on this side. So we need to move C to the other side. It becomes positive 6. Then this side is 0. So C equals to positive 6. All right. Because of the standard form, you see C is on the left-hand side. So then we have B squared, which is -4 squared, which is 16. Minus 4 times 5 times 6. Well, this is less than 0. So this is less than 0. So this gives us 2 complex solutions, which is number 3. Right? 2 complex solutions. So if solved, we have 2 complex solutions. So for A, we only have 1 solution. And for B, we have 2 complex solutions. Okay. Now let's see 5. Maybe I move up a little bit. The moving is always tricky. Okay, I guess I only have this spot. So 5 is a little bit tricky. It's in Ratner equation of the quadratic equation with this given solution set. So how do we do that? So this means we have x equals to 3 and x equals to -2. And this, we move 3 to the other side, becomes negative. We can write it as x minus 3 to be 0. And this one, we can write it as x plus 2 to be 0. Now, 0 times 0 is 0. We can multiply those two. That's x minus 3, x plus 2 equals to 0 times 0. Then we can multiply these two, get an x squared minus 3 plus 2, that's minus 1, minus x, minus 3 times 2, that's 6. That's it. So what is this? This is the opposite of solving the equation of x squared minus x minus 6 equals to 0. So it's just we reverse the order. Like given the solution, we want to go backwards to write the equation. For B is the same thing. So that means x equals to 5i, x equals to -5i. So this one we can write x minus 5i with 0, x plus 5i would be 0. Then we multiply those two. We get x minus 5i, x plus 5i. This is 0 times 0, which is 0. The difference of two squares thing, right? So we get x squared minus, we have multiply those two, x squared multiply those two. Remember what do we get? We get a plus 25 equals to 0. Then these two get -5xi. Multiply these two, get a positive 5xi. They cancel each other. So this is sum of two squares. It can be factored in complex number system. So again, you see, it's reversing. Right? If we're given this equation to solve, we would get two complex solutions. But this, we're given two solutions. We're going backwards to come up with the quadratic equations. Let's say 6, graphing. Okay, we want to graph each quadratic functions, identify x-intercept and y-intercept. Let's review x-intercept and y-intercept. X-intercept means all the points on x-axis. So you see all those points have y value 0. Okay. So y-intercept are the points on y-axis. All those points are y-intercepts. So the x value is 0. So let's first find x-intercept. That means y value is 0, right? So we start with this. We say, okay, negative x plus 2 squared minus 3 equals 0, right? The y value is 0, the function value. Remember f of x, just the old y, just this y here, that equals to f of x in this case. Then what do? We can move this negative 3 to the other side. We have negative x plus 2 squared equals to positive 3. We divide by negative 1 on both sides. This becomes positive, this becomes negative. Then we square root both sides. Get a positive, negative, square root of negative 3. We get x plus 2 equals to plus minus square root of 3. Then x equals to negative 2 plus minus square root of 3. Square root of negative 3. I'm missing negative signs. Okay. Then we want to write as x equals to minus 2 plus minus pi square root of 3, right? Square root of negative 3 is I square root of 3. Or you can write as square root of 3i. So the x-intercepts are complex numbers. What does it mean? This is complex. So we won't be able, so those are not, we won't be able to graph on this x-axis. So that means the graph of this function, because also we need to graph this function, will never go cross x-axis. It either go above x-axis somewhere or go down below x-axis somewhere. So when we have x to be complex numbers, all right? So how do we answer this question? See, x-intercept. We just see no x-intercept because the x value is a complex number. About y-intercept. Y-intercept means x value is 0. So we just evaluate f of 0. F of 0 equals negative 0 plus 2 squared minus 3. 0 plus 2 is just 2. So 2 squared is 4, but minus 4 minus 3, which is minus 7. So indeed, we do get y-intercept, which is 0, negative 7. So now let's graph this. So the first point you can graph is the y-intercept, 0, negative 7, which is here. We have this point on the graph. How do we graph the rest? We could use table value, or because we know quadratic functions are these ones, either upward parabola or downward parabola. Right? This is like when you diving, like a person diving into the water. And this is like a person throws a ball to his friend. So how can we tell if it's upward or downward? We look at the number. Remember the leading coefficient? If the leading coefficient is negative, we have a downward. If the leading coefficient is positive, we have upward. So this one is downward. So we know two things now. We know first, we don't have x-intercept. So it means the graph goes away from x-axis. Now we know the graph goes downward. And also we know the y-intercept is this. So either our graph on this side, like this, or our graph goes something like this. Because first, it goes away from x-axis because we have no x-intercept. Second, we have this y-intercept, 0, -7. Then third, we have the leading coefficient to be negative, it's downward parabola. So which one? Which one? So we need to evaluate. So let's try to evaluate f of 1, right? To see if f of 1 is this guy. Okay, let's evaluate f of 1. F of 1 is just negative of 1 plus 2 squared minus 3. That's negative 3 squared is 9, negative 3 minus 3, which is negative 12. So 1, we have somewhere 12, so point will be here. So we can see definitely it's not this one, right? It has to be this one, somewhere go, right? We have this point, 1, negative 12. So the graph looks like this. And we can get one more information by finding the vertex. So how do we find the vertex? Let me actually use different pen, different color. And this form is called a vertex form. We know the standard form, right? ax squared plus bx plus c equals 0. That's called standard form. So vertex form in function-wise, we have f of x equals to some a, leading coefficient, x minus h squared, then plus k. In this case, the vertex is h comma k. What is a vertex? V-E-R-T-E-X, V-E-R-T-E-X. So the lowest point in this upward parabola, also called the minimum, or the maximum point on the downward parabola, also called the max. So in this case, we have a maximum because we have downward parabola. And so this is telling us h comma k is a vertex. Well, what is h in our case? X minus h. So this is x minus negative 2. So in our case, vertex is x value is -2, k is -3. Because you see k is plus k. So here is plus -3. So -2, -3. -2 is here, -3 is here. So our graph on this side looks like this. It has to pass those points. But then parabola, downward parabola or upward parabola are symmetric. So if we have a point here, we have a point somewhere here. So the two sides have to be symmetric. So that's how we graph quadratic. No, this is wrong. It has to go through this 0, -7. All right. Okay, I know that's a lot. Let me try to do better with B. Let's erase all this. Let me try better with B. So we can always go back to table value, okay? Table value means you give x some values, then you evaluate f of x, then you graph those points, then you connect those points, right? But then let's find x-intercept and y-intercept first. X-intercept, remember the y value is 0. So in this case, that means x squared minus 2x plus 2 equals to 0. We could use completing square or quadratic formula. Completing square, we would do this. We would do x squared minus 2x Because we know x squared minus 4x plus 1 is perfect squared, as x minus 1 squared. Then move this one to the other side, it becomes negative. All right, after this now, we know we don't have x-intercept because we will get a complex numbers. We don't have to keep going. So we have no x-intercept, which means our graph will go away from x-axis. Now let's try y-intercept. Y-intercept means x value is 0. So f of 0 equals obviously equals to 2, right? Because you see 0 squared is 0, negative 2 times 0 is 0, so only left with 2. So we have 0, 2 on the graph. And because we don't have x-intercept, it's complex, and also the leading coefficient is 1, positive, so we know our graph will go upward. Yeah, go upward somewhere. We don't know. Our graph could go this way, our graph could go this way. It will be upward parabola and cross this point, this y-intercept, but we don't really know which one. Let me erase. Okay, how do we know which one? Well, let's try to find the vertex. We don't have vertex form. We have this standard form. So how do we find the vertex? Vertex x value is negative b over 2a. Remember, b is the number before x, which is negative 2. A is the number before x squared, which is 1. So negative times negative positive, 2 divided by 2 is 1. So x equals 1. Then the y value would be f of 1, which is 1 squared minus 2 times 1 plus 2. For those two cancel to get 1. So f of 1 equals 1. So 1 comma 1 is our vertex. And that's it. We're ready to graph. Why? Because of the vertex, through the vertex is also the line of symmetry. The left-hand side of the graph, we have this y-intercept. We have to have something like this. And then the graph is symmetric because it's quadratic. So that's it. We have this y-intercept. We have this vertex. Vertex is 1 comma 1. And we know the graph is symmetric along the line. So what is this line of symmetry? The line of symmetry has a name, x value equals 1. Because all those points on this line of symmetry shares the same x value, 1. Now let's see C. C, let's try to find x-intercept. X-intercept means the y value is 0. So x squared minus 4, the y value is 0. Then we can write as x squared equals to 4. We square root both sides. If we get a positive negative values, so x equals to 2 and negative 2. So we have two x-intercepts, 2 comma 0 and negative 2 comma 0. Well, let's graph that. 2 comma 0 is here. Negative 2 comma 0 is here. So I have those 2 points on the graph. Now let's do y-intercept. Y-intercept means x value is 0. So f of 0 equals 0 squared minus 4. What is minus 4? So 0 minus 4. So 0 minus 4 is a y-intercept. Well, the number before x squared is positive, so we know we have an upward parabola. And this y-intercept, well, let's check our line of symmetry, the vertex. Remember, vertex x equals negative b over 2a. What's our b here? We don't see x, right? We don't see x, that means we have 0 times x. So 0 kills x. So that means 0. So we have 0. So the x equals 0, x equals to 0 is the line of symmetry, which is the y-axis. So y-axis has another name, x equals to 0, because all the points on y-axis share the same value of x, which is 0. All right, that means in this case, the y-intercept and is also the vertex. So we can graph. No, this is supposed to cross this point. Right? The y-axis is the line of symmetry. Okay, let's proceed. I think that's it. That's lecture 18.